Hi everyone, in this video we will cover the rules of significant figures in calculations, and the objective is to apply the rules for significant figures in calculations involving addition, subtraction, multiplication, and division. Why this is important? When we use measured quantities in calculations, the results of the calculations must reflect the precision of the measured quantities. So we should not gain or lose precision during mathematical operations. Let's say I want to divide these two measured values over here. When I put this in my calculator, the calculator will give me as many digits as its screen can hold. However, not all of them are significant, and I have to determine how much I need to report. So this is what we are going to learn now, how many significant figures I need to report when I'm doing a mathematical operation. So when I count significant figures in calculations, if I have an exact number, because these have unlimited amount of significant figures, then I will not consider them when I'm doing the calculations. Or I do not consider the significant figures from them when I'm doing my calculations. And only the significant figures of measured value are considered. And to determine the number of significant figures in the answer, we follow two different rules depending on the mathematical operation we are performing. So there are rules for multiplication and division, and there are rules for addition and subtraction. And depending on which operation we're doing, we have to follow one or the other. So let's start with the multiplication and division rule. This rule states that in multiplication or division, the final answer is written to have the same number of significant figures as the measurement having the fewest significant figure. Let's consider this example over here. We are considering that all of these values are measured values. So we have 2.8 multiplied by 67.40 divided by 34.8. When I put this number into my calculator, then I will get this answer, 5.422988506. Now, what do I report on my paper? Do I report all of these numbers? Where do I have to cut these numbers? And this is when I have to follow this rule. This rule is telling me that the answer should have the same amount of significant figures as the one that has the fewest significant figures. You look at 2.8, it has two significant figures. 67.4 has four significant figures. 34.8 has three significant figures. My lowest is the two significant figure, then my answer should have two significant figures, and I need to round this answer to two significant figures, and that would be 5.4 only, two significant figures. So again, rounding rules are very important, so you have to review them if you don't remember them. Next example, I'm dividing 8.00 by 2.00. And I put this in my calculator and the calculator gives me 4. Is this the right amount of significant figures? Let's see. If we go back to my operation, 8 has 1, 2, 3 significant figures. The 2 have 1, 2, 3 significant figures. So my answer should have 3 significant figures, not only 1. And to add 3 significant figures, then I have to add zeros after the decimal place. And I have to report 4.00. And now I have 3 significant figures. So always in the multiplication and division, the answer reported should have the same amount of significant figures as the measurement that has the lowest amount of significant figures. Now we're going to look at the rules for addition and subtraction. In addition or subtraction, the final answer is written so that it has the same number of decimal places, and this is abbreviated as DP, as the measurement having the fewest decimal place. So here, I'm not counting significant figures anymore, but rather I'm counting the decimal places. Let's look at the example. If I'm adding 19.5 plus 58.33 minus 4.974, this is going to equal in my calculator to 72.856. Do I report all these or do I have to round? So what I'm going to do, I'm going to go back to my operation and look at these measured values and see how many decimal places they have. 19.5 have one number after the decimal place, so it has one decimal place. 58.33 has two decimal places. 4.974 has three decimal places. My answer should have the same amount of decimal places as the lowest. Therefore, it should have one decimal place, and I have to round it to one decimal place, which is the 8, and it rounds to 72.9. Again, if you don't remember the rounding rules, you have to review them. But here we put the 8 went up to 9 because after the 8 we have a 5. So then the last number to keep has to go up by 1. Let's practice. Round the following calculations to the correct number of significant figures. 12.18 times 5.2 divided by 3. If I put this operation in my calculator, I will get 4.872. So how many significant figures I have to keep? What I need to do first is count how many figures in my measured values. So here I have 4 sig figs. Here I have 2 sig figs. Here I have 2 sig figs. Then my answer should have the lowest, which is 2 sig figs. So then I have to round to 2 significant figures. So that would be 1, 2. So the last digit to keep is the 8. And I would get, and since I have 7, which is the first one to be dropped, then the 8 will round up to 9. So then I have to report 4.9. Next, 1.6 plus 23 minus 0.005. What do I get when I put this number in my calculator? So that would give me 24.595. Now, how many digits I need to keep? Since this is addition and subtraction, this is gonna follow the decimal places. So here I have one decimal place. Here I have no decimal place, so 0 decimal place. And here I have 3 decimal places. Therefore, my number should report 0 decimal place, and I would have to round it to that number before the decimal place. And again, this is going to round up because I have a 5. So then it would be reported as 25. Next, we will look at mixed operation. So what if I had multiplication, division, subtraction, addition within the same operation? Then what should I do? So when performing a series of calculations, we don't round until the end. So we don't adjust the significant figures as we go in the intermediate steps. I only have to round at the end. And for the different kinds of operation, we evaluate the significant figures in the intermediate answers, then do the remaining steps. Let's take this example. 3.489 times 5.67 minus 2.3. The order of operation is going to be the same order that you have learned in math. So first we do the parentheses. So 5.67 minus 2.3. And this is equal to 3.37. So first operation we did is a subtraction. Now we're going to multiply 3.489 by 3.37. And this is the answer we get in our calculator, 11.75793. Now I'm going to go back and actually evaluate the significant figures in my intermediate steps so I know how many significant figures I have to report. And I'm gonna follow the steps that I did. So first I did subtraction. And in subtraction, I have to consider the decimal places. So this one has 2 decimal place. This one has 1 decimal place. Then this number should have had 1 decimal place because it's going to follow the lowest. So if I actually round this to 1 decimal place, I have to cut it right over here. And if I do this, then that would leave me with 2 significant figures. Why do I care about significant figures? Because my next operation is a multiplication. So now I'm multiplying this number by this number. This number should have 2 significant figures. This number have 4 significant figures. Then my answer should have the lowest and should have 2 significant figures. So then I have to report 12. So I have to round to 2 significant figures. So again, for the mixed operation, we do the rounding at the end, and we have to evaluate the significant in the intermediate step so we can report our final answer. And here's a practice. Round the following calculations to the correct number of significant figures. So what you do is go step by step. So first in this operation, I would have to do the subtraction. So we have 12.18 minus 5.2, and that would give me 6.98. Now I'm going to divide by 10.1, and that would give me 0.69108911089. So this is what my calculator gave me. Now I'm gonna go back and double check the significant figures. The first operation here is a subtraction. So I care about the decimal place, and I have 2 decimal places here, 1 decimal place here. Then this number should have 1 decimal place. So I have to cut it right over here, which makes it have 2 significant figures. This number has 3 sig figs. So then my answer should have the lowest amount of sig figs when I'm doing the division. So that would be 2 significant figures. Remember, this is a trailing zero. This is not significant. So then counting two significant figures would be 1 and 2. And I have to cut it over here, round it to the second decimal place. So then would be 6, 9. And this is what we report. All right, that's it for this video, and I will see you in the next one.